So, flashback Friday, Further Maths November 1, question 1. This is a proof by induction. So, we go step 1, we're going to do the basis step. So, if we just let, throughout this question, I'm going to let f of n equal 2 to the power 3n plus 2 plus 5 to the power n plus 1. Now, if we consider f of 1 for our basis step, then we've got 2 to the power 3 times 1 is 3 plus 2 is 5, plus 5 to the power 1 plus 1 is 2, which is 32 plus 25, which gives us 57. And 57 is equal to 19 times 3, and therefore this is divisible by 3. So we've shown it to be true for the basis step. Now it's true for n equals 1. Second step, we assume true for n equals k, so f of k. So let's just write that down. So 2 to the power 3k plus 2 plus 5 to the power k plus 1. We know this is divisible by 3. So we're assuming it's divisible by 3. Step 3, let's consider f of k plus 1. So f of k plus 1 is going to be 2 to the power 3k plus 1, so that's 3k plus 3, plus 2, so that's 3k plus 5, plus 5 to the power k plus 1, so that's k plus 2. Now, if by laws of indices, if we want to try and compare it to f of k, so f of k had 2 to the power k plus 1, it had 2 to the power 3k plus 2. So we want to get 2 to the power 3k plus 2, and we've got a plus 3 left over. And similarly with the 5 to the power, we can do that as k plus 1 plus 1. And if we now use our laws of indices and separate that, we've got 2 to the power 3k plus 2 times by 2 to the power 3 plus 5 to the power k plus 1 times by 5 to the power 1. And so simplifying that, that's 8 lots of 2 to the power 3k plus 2 plus 5 lots of 5 to the power k plus 1. Now the key thing here is, if you look at the difference between the coefficients, we've got 8 and 5. The difference between those two numbers is 3. So that means that this should work, because we're trying to prove it's divisible by 3, and if the difference between those two coefficients is a multiple of 3, which it is in this case, this should work. So what we can do, and the method I use, is, okay, let's do f of k plus 1, and take away some amount of f of k. How much to take away? Well, it's usually easiest to make one of the terms disappear. So if I take away 5 lots of f of k, then I know that this term over here will become 0. So let's have a look. So I'm going to have 8 times 2 to the power 3k plus 2 plus 5 times 5 to the power k plus 1, take away 5 lots of 2 to the power 3k plus 2, let's put that in brackets, plus 5 lots of 5 to the power k plus 1. And if I simplify that, now I'm going to get 3 lots of 2 to the power k plus 2, 3k there. And the 5 to the power k plus 1 term has disappeared. So now I can say, okay, this has got a coefficient of 3, so it must be divisible by 3. And then that's that. And you just make sure you do your conclusion nice and clearly, put all the facts in, so it's true for n equals 1, assume true for n equals k, which implies that it's true for n equals k plus 1, and therefore by mathematical induction it's true for all by, ignore the handwriting, mathematical induction, therefore true, therefore by mathematical induction true for all n positive integers. Okay, so that's question 1.